I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. Here is a very special series for our grade 10 students who are following MPM2D. We'll take up quadratic expressions, Unit 5.1, multiply polynomials. I'm going to discuss the four topics here: understand distributive properties, binomial products, expand and simplify, and we'll take up thinking and application examples. Most of the examples taken here are from previous test papers. We'll also look into modeling, especially the two types of modeling, which is algebra tiles and rectangles. When we say quadratic expressions, the degree of polynomial is definitely 2. However, when you multiply binomials and trinomials, you may get higher degree. So we'll refer to them as polynomials in most part. We'll also see some examples where negative coefficients are involved. We'll expand and simplify cubes and take up applications based on area. There are 15 examples in all. Now let's look into the very first slide, which talks about distributive property and related methods. So before even multiplying the polynomials, let's understand the underlying property, which is called the distributive property. The example here is we need to multiply 2 into the polynomial x plus 3. Now this 2 will be multiplied by both x and 3, and then its sum will be written. So basically, the steps followed will be 2 times x plus 2 times 3, and the result is a polynomial, which is 2x plus 6. Now in this particular case, as you can see, this polynomial is linear. So when you multiply a constant by a linear term, you get a linear polynomial. Now let's also look into the model. How could you do with model? Now x plus 3 could be represented as a tile. Let's say this is a tile whose length is x, and then we have unit lengths of 3. So we have 3 units, 1, 2, and 3. On the other hand, we have two numbers which are shown here as two rows. Now when you multiply, what do you get? Well, when you multiply this x with a number, you get x. So I'll represent this with this green color, which is positive, and it signifies you the area. So when you multiply, you get these areas, which is x, and this is 1 and 1. It makes sense since 1 times 1 is 1, and x times 1 is x, and that is why you get these tiles. Green colors will signify for us a positive number. So whether it is x or whether it is a number. So the concept which you need to keep in mind here is that one time x is x and x times x is x squared. Perfect. So that is the concept. Now in this particular case, we are multiplying by 1, and so we get these units. The net result, of course, is you can just combine this. So get 2 x's and these 6 numbers, which is plus 6. As you see, it is exactly the same result as we got by multiplication. Now this is kind of a model which we'll be using here, and we'll refer this as algebra tiles. So the model which we have discussed just now is called algebra tiles, and I hope the concept is clear. We can also multiply using rectangles, and let me show you how we could do it. Now, in case of rectangles, let us say we have a rectangle whose length is x plus 3. So this is a rectangle with length x plus 3 and width is 2. So if I complete this rectangle, we can find the area of this rectangle. Here, let us say this is x and that is 3. So that is x plus 3. And the other side is 2 units. So when you multiply, you kind of get x times 2, which is 2x, and 2 times 3, which is 6. And you again get the same result. So it is a very simplified way of doing it. And you can also use this particular rectangle model to find the product of polynomials. So we'll call this as our rectangle model. Let us further explore how to utilize these models. This time we have an example where we are multiplying by x. The term is x plus 2. So when you multiply, again, apply the distributive property. So we'll multiply x with x and x with 2. X times x plus x times 2. We get x squared, and it is a good practice to write numbers first. So we'll write 2 first. This is also called the coefficient of x. So we get the result as x squared plus 2x. Now let's apply the tiles concept and see how it works out. So let me make a tile x plus 2 means 2 units. And there is only one column here of x. So when you multiply them, what do you get? You get x squared and 2x's. Which is x squared plus 2x. And as you can see, it is exactly the same result as we got earlier. If you apply the model for rectangles, if I have this side, which is x plus 2, the other side as x, and if I complete my rectangle with dimensions as x plus 2, let's say that is x, and this is x plus 2. In that case, what do you get? Area of the first rectangle is x squared, and the other one is 2x. And therefore, the result is x squared plus 2x. Exactly the same result as we got earlier. Perfect. So both the models will give you the same result as we have seen. Now let's take up more examples. Now this example is kind of typical since, let's have a closer look. We have 2 times x minus 4. So this time we are taking away something. Well, distributive property is straightforward. We can multiply by 2. And when you do so, what you get is 2x minus 8. No problems on this. How do we use the model? That is a big question. So in the case of a model, for x, we'll take x as such as we had been taking, but now we have minus here. For minus, we could take a different color, and we'll take blue as negative. So we have negative 4. So these 4 units, which I am drawing with a blue color, will represent negative 4, right? And positive in green. So number 2 will be represented on the left side as 2, And now when you multiply, remember one thing. Product of positive and positive is positive. Product of positive and negative is however negative. When you multiply same signs, you get positive. However, when you multiply opposite signs, you get negative. And that's the reason why I'm drawing these in blue now, the small units. Now let's count and get the result. So we get two x's which are positive, 1, 2, 3, 4, 5, 6, 7, 8 negative. And that is how we can actually model using algebra tiles. So as you can see here, I changed my topic and we'll use only one model when it comes to negative tiles. So here what we've done is that we are using 1 square as negative 1, right? Similarly, we could also utilize negative x as 1 unit shown here. And x squared with a negative sign will be kind of like this. Does it make sense to you? So that becomes a key as we move forward to apply these models and the distributive property to get our multiplication of polynomials going. Let's take up binomial products and related models now. Here in example 4, we have x plus 3 times x plus 2. We'll apply the distributive property first. So that is to say, with x, multiply both the terms, and then with 3, multiply them again. With the result, we are going to get x times x as x squared plus 2x, and then with 3 when you multiply, you get 3x plus 6. Now, whenever you do so, you will actually get some common terms which can be added together. So what we get here is x squared plus 5x plus 6. Now this process of adding the common terms is simplification. So we add common terms. Common terms basically means they have the same variable combinations. So can be added or subtracted. And this process is called simplification. So let me write this as simplification. So in the first part, we kind of expanded. So in the first part, we expanded. And the second part, we combine the like terms to simplify it. So that is what we'll be meaning by saying expand and simplify. Now let us see how to multiply or model the binomials. So let's take our algebra tiles. We could have a row and a column. So this time, let me take x plus 3 here. And x plus 2 on the other side. And when you multiply, you get x squared. And these are 3 x's. And in this case, a number with x will give you x. A number with x will give you x. 1 with 1 will give you a square here. So you get 6 of them. Now we can count and write down our result. So we got x squared, 2 x's, and these 3. So I'm adding 3 there, plus 6. So we can combine this and write down as x squared plus 5x plus 6. Does it make sense to you? Exactly the same result as we got earlier. Now, you can also make a rectangle. So a rectangle with dimensions of x plus 3 and x plus 2. Let's write down x plus 3 and this is x plus 2. So let's say x plus 3 is kind of this side and x plus 2 is like this. In that case, we do get an area which right here is x squared, and when you multiply 3 with x, this column is 3x. On this side 3 times 2 is 6, and when you multiply 2 with x, you get 2x. So again, when you combine, you get x squared plus 3x plus 2x plus 6, and the result is same, which is x squared plus 5x plus 6. Does it make sense to you? So that's the other model. Have a good look at it. This is extremely important. You see how we have related distributive property, the algebra tiles, and the rectangle model to signify binomial products. Let's take a few examples now. In this case, we have a negative term. So we'll use algebra tiles to model the situation. I would like you to pause the video at this stage and take this as a test question. We need to multiply the two linear terms, which are called binomials. They have two terms in it, x plus 2 times x minus 3. What will you get? Well, first we'll multiply with x, both the terms, and you get x squared minus 3x. And then we are going to multiply by 2, and what do you get? 2 times x is 2x, and 2 times minus 3 is minus 6. Now, we'll combine the like terms. These are the like terms which will be combined. So we have x squared minus x minus 6, and that becomes our result. Now, as far as the tiles go, we could take x plus 2. This is x for us, and then this is 2. And x minus 3, x minus means negative number. So we are changing the color to blue. So we have 1, 2, and 3, x minus 3. And now let's multiply rows and columns. So we get x squared here. These are positive, positive x, and positive x. Now in this case, when you multiply by negative, result has to be negative, right? So negative 1 times x is negative x, and negative 1 times positive 1 will be a unit with negative sign. So I'm going to repeat this process 3 times. And that's the result which we get. Now we can just count and write down the result. X squared, we got plus 2x minus 3x and minus 6. The like terms will be combined, so we get minus x minus 6, which is exactly same as we got earlier. Does make sense to you? So I hope this process is absolutely clear. Feel free to write your questions and submit your comments. Here is example 6 for you. We need to multiply 2 minus x with x plus 3. This is a test question. I'd like you to pause the video, answer this question, and then look into my suggestions. First, we'll apply the distributive property multiplying with 2. So what we get here is 2 times x is 2x, and 2 times 3 is plus 6. Now, minus x with the other two terms will give us minus x squared minus 3x. We should now combine the like terms, which are 2x and minus 3x. When you combine them, what do you get? we get 2x minus 3x as minus x plus 6 minus x squared. Now, it is a good practice to always write polynomials in an order with decreasing degrees. So the leading coefficient minus 1 for x squared, highest degree is x squared, 2 is the highest degree, that will come first, then minus x, and then plus 6. So what you note here is that whenever we're talking about polynomials, they should be written in decreasing order. Order of term degrees. Is that clear? It is essential. So we got our result, and now let us try to figure out how to do this question with the help of algebra tiles. So let's try to model this. We need to do 2 minus x with x plus 3. Let me take x plus 3 here. So let's say this is x, and then we have got 3 units. 2 minus x. For minus, we'll use blue color. So we'll say this is minus x, and 2 is positive, so green color. So 2 units. Does make sense to you. So now, let me rewrite here. We got x plus 3. Let me write x first. X plus 3. And on this side, we got minus x plus 2, right? So when you multiply positive and negative, you will get a negative. And this time, negative x squared when you multiply x with negative x. Negative x with positive unit will give you minus x, so that has to be drawn in blue. Blue signifies negative for us. So you got minus 3x. Here, when we multiply the positive with positive, you get positive. So all this will be now in green color. 1 times x is x, and 1 times 1 is 1. So 3 units. Then again, we'll repeat this pattern, and we get our result. Now, let's write down the answer. So we have minus x squared represented by this big block of blue, minus 3x, the other 3 plus 2x, and these 6 positive. We can always combine the terms, the like terms, to simplify, and we get minus x squared minus x plus 6, which is exactly same as we got using distributive property. So the algebra tiles is also a very easy method of multiplying binomials. Now here is another test question for you. I'd like you to pause the video and answer this question. You need to now multiply 2x minus 3 with 3x minus 4. We'll not make any tiles now. We'll focus on multiplication. So as I was saying, first thing is you have to multiply 2x with both of the terms. So that is the distributive property. So let me write down this as 2x times 3x, and then we have minus 2x times 4. And now we'll multiply with negative 3. So we could write this as negative 3 times 3x, and then negative and negative is positive. You could write positive 12 direct also. So here I've kind of mixed and matched these strategies. At times we do so, right? So sometimes when it is difficult to multiply the numbers directly, you may write like this. That's an idea. But if it is easy, just straight away write down the answer. So this is 6x squared minus 8x minus 9x plus 12. And combining the like terms, we get 6x squared minus 17x plus 12 as our result. Is that clear to you? Perfect. Let's take another example now. This time, we'll find out a square of a binomial. So we need to do what is 2x minus 3y whole square equals 2. Well, that really means that you're multiplying a binomial 2x minus 3y by itself. That is the meaning of square. Perfect? So we'll just do that and see what do we get. So when you do 2x times 2x is 4x squared. 2x times minus 3y, negative sign. 2 times 3 is 6. X times y is xy. Is that clear to you? So what we did was we are multiplying 2x by minus 3y. So you get a minus sign first. 2 times 3 is 6. Xy is xy. Let's look into it once again. When we multiply with minus 3y, what do we get? Negative and positive when multiplied gives you negative. 3 times 2 is 6. Y times x, yx. Now, minus 3y times minus 3y, minus 3 will make it positive 9. Y times y is y squared. Does make sense to you, right? Now let's rewrite this. We have 4x squared minus 6xy. Now remember, 6yx is same as 6xy. Commutative law. You can combine these now. So you get 4x squared minus 6 plus 6 is 12xy plus 9y squared. And so we get our result, which is, let me underline it, 4x squared minus 12xy plus 9y squared. Perfect. Now here is another question for you. This time we are going to multiply 3 terms. Now many times the question is, when we have something like minus 2 times 2y minus 3 times 5y plus 4, what should we do first? Should we multiply first by 2 or later? That is a big question. So I will prefer to actually multiply the terms first and then later by minus 2. So we'll prefer to multiply by minus 2 at the end. Reason is that we'll be working with smaller numbers, right? So the reason is to work with smaller numbers. Perfect. You'll appreciate it soon. So let's keep this minus 2 outside and we'll multiply the inside terms with distributive property. So we'll write this time as 2y times 5y. Let's think it's complicated. 2y times 4 is 8, so plus 8y. Minus 3 times 5 is minus 15y. Minus 3 times 4 is minus 12. Now, we'll simplify and combine the like terms. Here we get 10y squared. When you combine these two, you get minus 7y, 8 minus 15. And we have minus 12 here. Now we'll multiply by negative 2. So we get negative 20y squared. This becomes positive 14y. And that also becomes positive and 24. Now in this case, you've seen we multiplied by 2 at the end. And so we were working on the whole with smaller numbers, right? Let's take another example. This is again a test question for you, seen many times in previous test papers. You need to expand x minus 2, which is whole cube. What does it mean? Well, it really means we have to multiply x minus 2 by x minus 2 by x minus 2 itself 3 times. Correct? Now, in such cases, what are you going to do? Well, you could select any two of them, they are kind of similar, and then multiply with the third later. So that is the approach. So we'll write this as x minus 2 within our brackets. We will multiply these. So we get x squared minus 2x, and when minus 2 is multiplied, we get minus 2x plus 4. Combine the like terms before opening this bracket. So we get x squared minus 4x plus 4. And now apply the distributive property. Multiplying with x first gives you x cubed, and then with minus 4x squared and plus 4x. We'll actually land up with 6 terms, as you can see here. Right? Combine the like terms. When you combine the like terms, you're going to get, let's identify these. So these are the 2x squared terms, and these are your x terms. Minus 4x squared and minus 2x squared is minus 6x squared, plus 4x and 8x is plus 12x, and we have the number 8. So this time we get a cubic polynomial, right? So we are definitely giving title as quadratic expression. But when you multiply polynomials, you could get higher degree polynomials. Let's look into the next example, which is again a combination of multiplication, addition, and subtraction. So let us see how to do this kind of question. What we have here is 2x times x minus 1 minus 3 times x minus 3. Apply the distributive property. So we get 2x squared minus 2x minus, it's better to use square brackets, negative outside, open the bracket. So we get 3x minus 9. Now we can open the bracket. So we get 2x squared minus 2x minus 3x, the sign changes to positive, and combine the like terms. So we get 2x squared minus 5x plus 9, and that becomes your answer. Does it make sense to you? So that is how we are going to solve such questions. Another question for you, slightly difficult than previous. I would like you to pause the video and answer this. Well, here we have x minus 2 times x plus 1 minus x plus 3 times x minus 3. So as I was saying, we'll maintain brackets around the negative terms so that we avoid confusion. It is a good technique. Now let's expand this. So we get x squared plus x minus 2x minus 2, and negative of, multiply these, x squared minus 3x. So you know how we got it? X squared minus 3x, now 3x minus 9. So we get 3x minus 9, correct? Let's open the bracket now and combine. So we can combine these two at least. Open the bracket, so we get what? Signs will change. Well, you do notice one thing, that this term here, minus 3x and plus 3x, becomes 0, and therefore we'll just neglect it now. Minus and minus becomes positive 9. Perfect. Since this is 0 for us, so minus 3x and plus 3x is 0. So we get only 9 there. Now combine the like terms. When you combine the like terms, what do you get? Well, x squared minus x squared is 0. You get minus x, and minus 2 plus 9 is plus 7. So you get a linear result. So when you multiply even binomials, it is not necessary that the answer will be a binomial. Does make sense to you? So this is a very important note for you. So you might get linear result. Well, for that matter, you can also get constant or even a zero. Zero is also a constant, right? So in these operations, when we are doing multiplication and simplification of polynomials, you could expect any degree, right? Okay. Now let's move into the application questions. The question here is, a rectangular skating ring has length of 7x plus 3 and width of 5x minus 2. Express the area of the skating rink as a polynomial. So, well, let's say we have this rink and the dimensions given to us are 7x plus 3 and this is 5x minus 2. Area is length into width, right? So area is basically length times width. So we can write area as 7x plus 3 times 5x minus 2. We can apply the distributive property and expand and simplify. So that will give us the result, right? So let's do it. 7x times 5x, 35, 7 times 5, x squared. With minus 2, we get minus 14x. 3 times 5 is 15, x minus 6. And that gives you a value, let me write down here, 35x squared. Combining the like terms, we get plus x and minus 6. So that is our answer as far as area is concerned. Now, when units are not given to us, well, later we are given the unit meter. At present, we can write unit square. So that is our 13a. Now let's do part B. In part B, we're saying if the value of x is 3 meters, then find the area of the ring. So we know x is equals to 3. So we get area as equal to, substitute 3 now. So we get 35 times 3 squared plus 3 minus 6. So that means 35 times 9 and we have minus 3. 3 minus 6. Let's multiply by 9. 9 times 5 is 45, 4. 9 times 3 is 12, 9 times 3 is 27, and 4 is 31. So 9 times 5, if you say 10, so it is 350 minus 35. You could say that, right? And get 315. Minus 3 will give us 312. Units will be meters squared. It's very important to include units in your answer. So the area will be 312 meters squared. 2 more questions to go, rather 3. So it's again an application question. The question here is, a square has side length x. One dimension is increased by 3 meters and the other is increased by 5 meters. Write algebraic expression for the area of the modified square. Part B is, find an expression that represents the increase in area, and C is, if x represents 6 meters, find the increase in area. So let's begin by sketching the square itself. So we have a square here, says x units. Now this square is increased by 3 meters and the other side by 5 meters. So let's increase this by, let's say, 5 meters here and 3 here. So we get a new square. Dimensions for this will be x plus 5 and that will be x plus 3. Now we need to find, part A is Write algebraic expression for area of the modified square. So the modified square area A will be x plus 5 times x plus 3. So when you multiply, you get x squared plus 3x plus 5x plus 15. And you can write this as x squared plus 5 and 3 is 8 plus 15. So that becomes part A, area of the modified square. Part B is find an expression that represents the increase in area. Now increase means what? Increase means this area, take away the earlier area which was x squared, right? That will be the increase in area. So we can write down this as x squared plus 8x plus 15, take away x squared. And what we get here is x squared and x squared becomes 0. So that cancels. And we have 8x plus 15 as our increased area. Now, part C is if x is equal to 6 meters, find the increase in area. So 14C is when x equals to 6 meters, then increase area, let me write delta A. So I'm going to substitute 6 for x. We get 8 times 6 plus 15, 48 plus 15. And when you add it, 5 and 8 is 13, 3, 1. And 2 and 4 is 6, 63. Units are meters squared. So it's kind of important to understand that units are important. Include units in your answer. So the increased area is 63 meters squared when x is equal to 6 meters. Perfect. So let's get back to the last two application questions. Question 15a. Write two different algebraic expressions for the area of the given figure. So that's the figure given to you. I'd like you to pause the video, write down this expression for area. Now that too, you need to write two different algebraic expressions, okay? And part B is expand and simplify your expression to show that they represent the same area. So let us see how to write down two different expressions. Well, what I can do here is divide this into two different rectangle combinations. So if I do this combination, then I can write area as equal to area of this square, right, rather rectangle, and the other rectangle. So that is my first combination. So area will be x plus 7 times 6. So that becomes the area of, let me highlight this in a lighter color. Okay, right. And then we'll add the other area, which is this area. That is 5 times that length. Now, how much is this length? Well, this length is x plus 9 minus 6, which is x plus 3. Perfect. We have to take away this length 6 to get the remaining, which is x plus 3. So the area for this smaller rectangle will be x plus 3 times 5. So let's multiply. We get 6x plus 42 plus 5x plus 15. And we get 6x plus 5x is 11x. 42 plus 15 will give us 7 and 5, 57. So it was only to write an expression, which is this part. So that is the expression for 1. So let's call this as area 1. Now, can you divide this into a different form? Of course we can. Let's use it in a different way. So let me now divide it like this. In that case, I get one area which is kind of like this. Now that could be 5 times x minus x plus 9 times 5. So I could write this as x plus 9 times 5 plus the other area, which is this one. One side is 6, the other one we need to figure out. The other one should be how much? Well, this will be how much? X plus 7 take away 5, right? So we have to do x plus 7 take away 5. So we get x plus 2. So x plus 2 is the dimension of this side. So we are going to multiply 6 with x plus 2. Does make sense to you? And now we'll just expand. So we get 5x plus 45 plus 6x plus 12. Combine the like terms. 5 and 6 is 11, and 12 plus 45 is 57 plus 57. So what do you notice? We notice that we have the same terms. Perfect. So actually speaking, we had to write two different algebraic expressions for the area of the given figures, and second part is expand, simplify your expression to show that they represent the same area. Well, we got the same area. We know that now A1 is equal to A2, and both are equal to 11x plus 57 unit square. Perfect. So that is how you could do such a question. Let's take up the last question here, which is find an area, find an expression for the area of the given trapezoid. Area of a trapezoid is half the sum of parallel sides times height. So that is given to you. You are given expressions for the side lengths and the height. I'd like you to pause the video, answer this question. Let's write down the expression. We have area A equals to half of sum of parallel sides. Now the two parallel sides are these, right? These are parallel sides. So we'll add them up. We get x plus 1 plus 3x plus 5 times the height, which is x plus 2. So let's simplify. We get half of x plus 3x is 4x, 1 plus 5 is 6 times x plus 2. Now it's a good idea to multiply by 2 first. So we'll get, divide by 2. So half of 4x is 2x and half of 6 is 3. So we get a simpler expression to multiply with, and that is why I use this now. Now we'll apply the distributive properties, multiplying by 2x, both the terms, and then by 3. What you get here is 2x squared, 2 times 2 is 4, so get 4x. 3 times x is 3x, 3 times 2 is 6. And you can combine the like terms, you get 2x squared plus 7x plus 6 as your answer. Is that clear to you? So with this, we come to an end of this video, and I hope you have learned most of the concepts required for this particular chapter. So we have understood how to apply the distributive property and multiply polynomials. We have also seen different models, specifically two of them, one using algebraic tiles and the other one using rectangles. We also worked with negative coefficients where we used blue ink for negative. We worked with cubes and with area. We also noticed that when you multiply polynomials and simplify them, the degree could be higher and it could be lower also, as some common terms can cancel away. Always remember to write your answers with units in decreasing order of degrees. With that, we come to a conclusion of this video. Feel free to write your comment, share your views, and all the best. Thank you.